I'm here today because I love Ruby, and I hope you are too. Let me show some hands.
Because I hate jobs.
Also very good, valid reason. We accept you here. But yeah, Ruby just allows me to write some really elegant code. It doesn't get in my way. I can just be a happy developer, which is the intended purpose. But maybe more controversially, I also love metaprogramming a lot. Maybe it's because of my day job, but yeah, I've been burnt by the metaprogramming flames before, so I kind of know what not to do and what to do. So I hope that you can trust me a little bit about what I'm talking about today. My name is Tom de Bruijn. I go by Tom Bruijn on most platforms, and I'm a developer at the aforementioned AppSignal. We are an APM. We track errors, performance, metrics, logs, all kinds of things. But originally, it started with just a Ruby gem. Just a Ruby gem to monitor some Rails apps and maybe get some useful data out of it because New Relic was getting too complicated, right? So it started really simple, but it started immediately with metaprogramming because the first thing we had to do is like hook into Rails and get data out of it. And since then, we've added support for Sinatra, Hanami, delayed job, all kinds of gems that too many to list. But you know, you add in a Ruby gem, you authenticate, and then it should just work. You should just get all those metrics and all that data. Unfortunately, this is the real world, and things don't always just work. So over time, we've had a lot of support issues from people saying like, hey, great Ruby gem, but I just don't see any data, or it doesn't work. And that's had become a real headache to figure out because everyone's situation is different. Everyone has very creative solutions to host their application. And we have to figure out why it doesn't work on their specific case. So to make our work a little easier, we made a tool called the Diagnose Report, which you see here. Our Ruby gem collects like more than 100 data points, throws it all in a big JSON, and sends it to our server, after which the server will validate it and show you this somewhat passable HTML that I quickly put together. So yeah, in theory, like this should help us a lot. Like even the user that submits the report can use this UI to like see like, oh, I forgot to set the app name or something's wrong with my config, that kind of stuff. They can help themselves. And if that doesn't work, we can start taking a look and maybe find a new situation, new problem we haven't encountered before. Unfortunately, while this is great, a great solution, maybe biased, but it is an unmaintainable mess, this system powering this. And I'm talking about the server side, not the Ruby gem, because the Ruby gem is fine. But I quickly put together something like a couple of years ago to show this report, and I hadn't really had the time to improve it since. And as a result, my colleagues have complained about it being inaccurate, which, you know, fair. This is kind of what it looks like. This is just one small part of like 12 sub-reports in here. Don't try to read it, it makes me cry. What I want to zoom in on is this part. This is how we define a data point in this JSON, which is just a hash inside another hash. And it has some magic keys like label and required and highlight, which I actually don't know what highlight does anymore, so that's fun. Validate is also there to like do another validation, although required is also there. Right? It's confusing what's going on here, but also there might be other keys in here that you just have to guess are there or copy from something else. So it breaks a lot, it's fragile. I wish it was tested better. But anyway, it has to change, right? Because I have trouble maintaining it. My colleagues don't want to touch it, don't want to go near it. So we're going to instead make something new. We're going to craft a new elegant DSL in Ruby. But first, let's get some terminology out the way, because what is a DSL? If you're like me, you can only fit so many three-letter abbreviations in your brain because everything is shortened now, and I have no idea what this stands for. But even when I look at the definition, it doesn't really spark my imagination because I'm like, what? Okay, specific language I can kind of figure out, but what is the domain in this case? Where do I go in my browser? What do I type in, right? So let's look at some domains we do know. And the first one is probably very familiar to everyone, which is like a getter-setter principle. If you're from Java, you might remember having to type everything manually, and in Ruby, we just use these helpers to generate some methods for us. If we use a gem like rake, it has a nice DSL to generate command line subcommands. So in this case, we just have a hello, we pass in a block, and then we can call it from the command line, and it just works. We don't have to figure out how CLI works. Rake does it for us. But your app may also explicitly or implicitly already have some kind of DSL going on. You might not intend to, but you made one accidentally. Because just how code evolves. As teams work on things, they kind of want to introduce some kind of pattern or make something easier for themselves, so something starts to evolve. A DSL is really just a bunch of terminology about the problem domain and the way we interact with it as defined by team preferences, or the author, or single author in this case. So, why would you want to use a DSL? Maybe it's a question you'll be asking, because I'm trying to sell you on it a little bit. Think of it like an API, but it's friendlier. Because if I bring out the inner Java developer, which I once started with, out, and I try to make a API kind of thing for the Glimmer gem, which you can see on the right, I kind of know which one I prefer. Because if I just look at the code on the right, it is very clear what is the hierarchy here, what belongs to what kind of attributes does a button have, for example. While on the left, I kind of have to read everything to figure it out. So it should make things like configuration easier. Right? If you use Rails, you don't have to fork it just to change the time zone, which is always nice. And there's even some like custom DSL for, some DSL for custom config options, which you don't have to define in Rails. It just, you write it and it works. Best of all, no YAML required. We might write some specs in it, but for Rails, we don't need to use YAML for most part just to configure it. Another great reason to use DSL is to automate writing code. And I'm not just saying Ruby code. I haven't written any SQL in years, which for various reasons, but also whenever I write a migration, I just don't have to think about how to create a table. I can just write this, Rails will figure it out for me. It will also figure out how to drop that table if I ever need to. As I showed before, rake is very nice, and it makes things like high churn code more easy to maintain. Because if I have to implement a rake from start, it will be much more complex than what's going on here. But I will end up with some kind of case statement that I have to go back to every time I want to change something, which is just not a fun experience and will probably break. Yes. Hopefully, a DSL might also make things easier for non-developers. I was at Yoruko, where the original author of RSpec was telling a story that he was writing some tests or changing some tests, and someone, a non-developer client, was sitting next to him and pointing out the mistake in his spec. They could read the RSpec code as if it was just English, which you kind of would hope makes it easier for everyone to just use a DSL. I'm not saying that's the purpose, but it would be nice. So, are all DSLs good, you might be asking? If my clicker would work, yes, there we go. It should make the reading and writing of code easier. We read code a lot more than we write it. If it's easier to read, hopefully makes it easier to maintain as well. But we fear what we don't understand. And I heard someone at this conference already say, you don't dislike DSLs, you might just dislike bad DSLs. And people have jumped to the conclusions over the last couple of years, maybe more than previously, that any DSL is a bad DSL, just because it's a DSL. I've been part of discussions about this, and people just want to instantly dismiss something because it's a DSL. RSpec is a very infamous example. RSpec, like Rails, has some metaprogramming going on for its DSL, and people, they just dismiss it because they would rather use minute tests because they don't like how the RSpec DSL works. And I can understand the confusion in some areas, like if you use RSpec and you know the difference between let and let exclamation mark, you might understand why that might be hard to keep all in sane in your brain. But by reading some documentation and like using it, just using it, you usually figure out how it works. And it might take some time to get used to, but eventually, I hope it will work for you. I do want to say I love RSpec. It's great. I use the DSL a lot, and I wouldn't want to switch away from it. But I think most people use it, but there is a vocal minority that really does not like RSpec. But today, we're going to be creating our own DSL. We've looked at a little bit of like why you would want to make one, but now we're going to look at how. This toolbox will show up once in a while. We're going to put new tools in that toolbox to make our DSL. But the problem domain of our DSL that we're going to make is the diagnose report representation. So that is the thing we're going to solve today. This is kind of the DSL I settled on. It has a lot less syntax going on. It uses some blocks. It has method calls in there. This is what we're going to try and make. So let's rewrite. Sorry for the back and forth. The first thing we're going to start with is accessors, because most times you have some kind of data structure you want to represent in Ruby. You start off with accessors. You make a class, you add some accessors to it. Now you can set the data on it, and it'll work, right? We can set the data, that's fine. But I have some extra requirements, because I want to be able to fetch all the attributes in one go, which doesn't really work with attribute accessor, unfortunately. So we're going to have to make our own methods, which means we have to write a lot of them, which doesn't help with the maintainability. So instead, we're going to write our own methods dynamically, using some metaprogramming. I pressed it once. I might just drop it. Okay, here we are. We have our DSL. We have a config report class, and it has an attribute method, which you call at the bottom there, to define what kind of attribute exists on the report. So far, so good. In this method, though, we're going to define a new method using the define method. It just becomes very meta here. What it does, it just accepts a name for the method, and if you pass a block in it, it will become the method body of the block, for the method, sorry. Really, these two things are basically equivalent, something similar that Xavier showed earlier. Yeah, this is just a metaprogramming to accomplish the same thing without you having to like string eval a bunch of code. If we want to create a writer method, we can do the same thing, just add an equal sign at the end, and Ruby will figure out the syntax magic for this. We merge all the metadata with the value so that we can have all the things in one place. And then the DSL works roughly the same, but I have this extra method here to fetch all the attributes. But it's still using hashes. I figured out that I'm not the person that likes hashes for my DSL, so we're going to use blocks instead. And blocks are great. We use them all the time. That's one of my favorite features in Ruby. But we're not going to use it to iterate over anything today. We're going to use it to configure something, which will be our attribute. You can just pass in a block to a method like this by using the do-end keywords. To call that block in the method, you just use the yield keyword here at the last line. And if you want to pass an argument to that block, you pass an argument yield, and it will figure it out. In this case, that is our attribute DSL class here, or instance of it anyway. And now in that block, you can just call the method to set the label. Very briefly, DSL class, maybe new concept. I like it a lot to just we should maybe say I am a single responsibility fanatic. please split your code into things that just talk about one thing. So an attribute DSL class like this would just be used to define, just be used when you define your DSL. It's a concept also used by the Puma gem, which you saw earlier because of my slide mishap. It just loads the entire file, the Puma RB file, and just throws it into their Puma DSL class, calls all the methods, and at the end they just extract some hash with all the options set. So, great, we know how that works. But there's still too much syntax going on here. I didn't really like passing in the attribute argument and then fetching it again in the block. I really just want to call label here directly, which we can do by using instance eval. Instance eval is a really great tool. I mean, I like it a lot for making my DSLs. It allows you to change the context in which the blocks are called, not from where they're defined, but where they are evaluated on, which in this case is our attribute DSL instance. You also have to explicitly pass in the block, which you do by the ampersand here. But when that block is then called, you can see that the self has changed, or the self has become the attribute DSL instance here. So when we call label, we can call it directly on the attribute DSL instance. Really what's happening here is just this, but in a fancier way. You might be asking, okay, great, you've showed me 2 ways to call blocks, but which one to use? Well, I have a preference for instance eval. It's mostly personal preference, like just use what you think works best for your DSL. I wouldn't want to limit myself to just one. I would use it for other things, for like this check block, which are the terminology I use for validations, because it's not just errors. Here I want to be more explicit what I'm actually calling the value on, what I'm setting the error on. So I'm passing in the attribute argument to the block, and then I can explicitly call those methods on the attribute variable here. Yes, to then use those blocks later, if I don't want to use it immediately, don't want to call it with yield or instance eval, I can also just throw them on an array somewhere and just call it whenever I parse my JSON. Okay, we're at the halfway checkpoint point, which is about right, according to my timer. What can we make? Well, we can make this DSL. We know how this works. We have the building blocks so far. I would say you're like most of the way there for just like have some kind of nice looking DSL, like that works. If you're an aspiring gem author, you can also make this, which I think, I wanted to do initially when I was looking into meta programming for this kind of thing. You just have to, add the business logic that actually does anything with all that DSL magic. So, next problem I have is, like I said before, I have multiple reports. I have about a dozen, all kinds of different contexts, and one of them is the language report. The language report and the config report don't have the same kind of metadata per attribute. In this case, the language report has some kind of metadata for what kind of language it comes from, because we support multiple languages. So if there's a field that only applies to Elixir, I don't want to have it show up in my Ruby gem validation report, because that will just confuse any Ruby developers out there, and that's not helpful. So if we have some kind of behavior that we want to share between classes, but it's not identical, first things we usually start off with is just a module. Modules, really quick recap. You can use modules to extend the class. That will mean that any method defined on that module will become a class method in the class. If you use module include, it will instead include all the methods on the instance level. So it means you first have to initialize the instance of the class, and then we can call the methods on it. For this example, we're going to use extend, so we're going to use class methods. That allows us to define these def metadata methods, which we can then call. And this kind of works. But I'm not happy with this, because now I'm shifting a lot of responsibility to my end user to say, create your own attribute class inside the report class, extend a bunch of stuff, and then call the methods to define the metadata for every attribute. I could make this better, I guess, but I don't want to. Because what we're going to do instead today is dynamically extend our DSL by using another DSL. We will introduce plugins to this DSL. A plugin might look like this. We create a new class that's called the label plugin, which extends some kind of plugin class, defines what kind of metadata that plugin manages, in this case, just the label. I pressed the button. Then on the report, I include that plugin, and then on the attribute, I can actually call the label method. So I've moved a bunch of logic around, but now I can call the label here for the attribute. But this seems maybe like a bit of overkill, like too much work for just simple metadata stuff. And that's true. I would want my plugins to do a lot more. I would want to make a required plugin that also immediately validates it, so I don't have to inline validate everything myself. So for this kind of plugin, it would be nice. You can just extend it with whatever behavior you want. Which I really like, because if I'm shipping this in a gem, which I intend to do, it means my gem has a lot less bloat going on. There's a lot less code that I personally maybe don't want. People have submitted upstream of like, hey, you should have this kind of validation or this kind of metadata. But like, I don't use it, so I kind of want to reject it because I would have to maintain it, which I don't want to do. Like if I don't have code that I don't personally use, I don't understand. Thank you for the next point. My computer has its own will. Yeah, so I don't have to maintain it, and the user can just customize it to their own wishes if they have a plugin system that they can just extend the behavior with. So to make plugins, we're going to simplify the metaprogramming a little bit, because not because metaprogram is complicated, because I want to focus on the problem at hand. Like before, my report just has some kind of attribute class, which will extend some kind of metadata module, and then we'll define the metadata on it. We know this so far. But as I was doing metaprogramming stuff, I came across this, which the first time I saw it, the Ruby interpreter in my brain was like, syntax error. This doesn't work, Tom. Stop doing that. But this actually works. This is a really cool pattern. We've seen something already from the keynote. We can use module new. Module new will create a new anonymous module. And as long as we just return at the end there, when we then include it or extend it in the previous slide, we just include the module new. These two things are basically the same. An anonymous module will just be a module without the constant defined, but instead it will be defined on a variable. And then what's really happening is just this. But this is not very interesting, because now we just have an empty module included or extended. So what we're going to do instead is we're going to use the metadata passed into the define method to iterate over, define methods for every metadata on that specific module we're returning at the very last line. And it will look something like this. The generated code will return some anonymous module, which looks like this. So we'll have these two methods. Then we extend it in our class, which will move the code around to, or rather copy the move around the code to the attribute class, and it will just work. We now have a module included, but it's never defined on a constant anywhere. And I really like this approach because it's very clean. It's just one line, and it does exactly what I want. I don't first have to check if the metadata module is included. I don't have to pollute the class namespace to make sure like there's some kind of defined metadata method in there. The class doesn't know how to make those kind of methods, which, again, the single responsibility fanatic in me is very happy about. Because I could just move it to a module and then include that module, but then the class that includes it still knows about it, which I don't want. This pattern is called the module builder pattern. This is a really good article by Chris Salzberg. I really recommend everyone reads it. It's a bit of a long read, but it goes into so many use cases for this kind of pattern. It's really, really interesting. So let's go back to making plugins, because that's what we started with a bit while ago. I want to make my report have some kind of plugin method, which then gets called on the specific reports. These plugins will then be passed into the attribute class, and there will be some stuff going on to make that work. Then I have a problem, which, I mean, it works, right? This works, but the intent is that not work. That last line shouldn't work because I haven't included my label plugin to the language report. Why is that happening? Well, I made a mistake in my previous slide where I just included it all in the attribute class, which, I mean, it should work, but the problem is that when I extend my config or language report from the parent report class, subclasses from the report class, like attributes, don't immediately get subclassed as well. So instead of just throwing it to the attribute class, we're just going to store it somewhere, and then we're going to do something else that was shown earlier today. We're going to create a new class dynamically. We've seen this slide before in the previous talk. This just works. We can define a new class by using class new, and if you pass in an argument to class new, it will extend from that class to make a child class of, in this case, the attribute class. So now we have a new attribute class for every report, or in this case, every attribute. So we don't have to worry about plugins accidentally being loaded in one report and not the other, or other way around. We just pass in the plugins. The plugins will extend or include their class level or instance level DSLs. We'll use the same pattern as before. We'll create a new module, make sure we return it. We add all the metadata methods on it. And then finally, we have this DSL. We define the two separate reports. They have their own plugins. Then we can use those methods defined by those plugins on the attribute to define whatever metadata they have, and then our DSL is done. So, now that it is done, let's do some reflection. What did I learn? I already used metaprogramming a lot at work. This is kind of my job. But it's very different because this kind of metaprogramming should be invisible, like what I do. If people know that I'm metaprogramming in the Rails app, I'm doing it wrong because it will either be an error or there will be some performance regression. People will know we're there, and it's not supposed to be the case when you're an APM. But for a DSL, the purpose is to be very visible and be, hopefully, friendly. The interaction should be, acceptable, adequate, I would say, to any user, that they can easily read the DSL and interact with it so that it doesn't become a chore, there's not too much syntax going on or any other things that people say, I don't want to use DSL. As a result, I do love Ruby more. Like, it just allowed me to look at it from a different perspective, all these metaprogramming tools we've collected during this talk. And yeah, I can write a really nice, elegant DSL. So, what did you learn? Well, I hope today has given you some insights on why to use a DSL, because, or rather, maybe you have some kind of idea brewing, you've made your own gem using a DSL, all kinds of reasons. Do experiment, please. You also know a little bit about how DSLs work, how to make your own. Maybe you've looked at some new metaprogramming techniques before that you haven't seen before today. Maybe more importantly, at least that would be my personal, what I would want to accomplish today is that you don't fear metaprogramming and you don't fear DSLs, or at least less. When I was at Yuruko, Masafumi Okura gave a talk about RSpec and how the internals of RSpec worked, and this was one of his slides. Metaprogramming is just programming, and it's quite readable, but it's maybe not the Ruby you're familiar with, but it is still Ruby. So, we have started off with this, which, mind you, I still have to maintain, to this, which I hopefully, like, whenever my gem is done, I can throw in to the code base, take out all the old crap, and ship to production. And hopefully my colleagues can also work on it then. Oh yeah, and I've even gone further, like make nested attributes work, and that was a whole headache, but it all works. So, at the end, we have collected our toolbox. We have all these tools. We know accessors already, hopefully before this talk, but now you can make your own by using define methods. There are at least 3 ways to call blocks, and now you know them. I personally really like DSL classes. It's a pattern I really want to use more, but I couldn't find to fit it in otherwise. Modules, of course, we know modules, how they work, but hopefully maybe you've seen some other ways and creative ways to use them, like dynamic class and module creation. And I brought it all together in some kind of plugin system, which I hope you agree is kind of neat. You're ready to make your own DSL. And I encourage you to at least try it. So maybe if you're on the fence of like, I don't like a DSL, try making one yourself. Hopefully it will make it easier to understand. Maybe there's less confusion or hesitancy to use a DSL. If you want to see this code that I showed on the slide today in action, you can look at it at this repository. It is definitely a work in progress. It's not done yet, but I will continue to work on it here. But please help me think of a better name than schema. It is a very generic name, which probably is taken on Ruby gems. I'm terrible at naming things, so if someone has a better idea of this kind of DSL, please let me know. And I want to say thank you today for listening.